All right, everybody, we have finished up our discussion of urbanization, and we are going to move on to discussing transportation. So when we're talking about transportation, we are talking about standard 5B.4, and that discusses how human populations must design systems to allow for efficient transportation from one place to the other. So as we're talking about transportation, we're going to talk about how it's evolved, what current methods of transportation we have, and how they're regulated. Talk about personal and public transportation, identify new methods of powering our transportation, and describe ways in which transportation affects urban area development. So the first question is, how has transportation really evolved? And you see here in this infographic that we really focus on 6 major steps in the transformation of transportation. So most of human history, people walked. When we started domesticating animals, we would ride horses, donkeys, camels, wherever you were in the world, whatever was indigenous to the area, you domesticate them, you ride them. Then eventually we started moving into the wagons, the carriages, the buggies, prior to the Industrial Revolution. We also have sea travel, which is something that goes back to the ancient world. But it became widespread, common, and global in about the mid 1400s with the beginning of the New World explorations by Portugal, Spain, and the Dutch. Once the Industrial Revolution hit, we started developing railways and trains as a way to transport people and goods. And that became very commonplace until the advent of automobiles and aircraft. In the early 1900s, we developed air travel at Kitty Hawk, North Carolina, and began with very small one-man aircraft, and now we are capable of carrying large amounts of people or cargo very long distances very quickly. And the late 1800s saw the development of the first automobile prototype by Carl Benz, which influenced Ford in designing his automobile here in the United States. Now, the automobile is one of the most common, if not the most common form of transportation we have around the world today. So in the United States, one of the big things that transformed how we do transportation really came in 1956 when this man right here, former general turned president, Dwight D. Eisenhower, signed into law the National Interstate and Defense Highways Act. And what that did, if you look at the bottom right hand of your screen right here, it developed what we know today as the Interstate Highway System. So what you see there is the early drafts of what that interstate highway system was going to look like, particularly very concentrated on the East Coast, and also some major highways concentrated on the West Coast. The interstate highway system was really designed for the purpose of making it easier to transfer military personnel and military equipment from one side of the country to the other. Prior to this, the states were responsible for maintaining their roadways, and it was very difficult to find good roads all through the United States. And Eisenhower decided to bring this before Congress and actually kind of get this rolling when he was a general in World War II, and he saw the efficiency of the way that the Germans moved their military around, particularly using the Autobahn highway system, which you see right here in the bottom left-hand corner. This is actually a picture from 1945 of the 9th U.S. Armed Cavalry moving out of Germany. So when we talk about transportation evolving, we have to talk about how it's going to impact our urbanization and how are we going to regulate it. So when we have the ability to transport ourselves and our stuff wherever we want to, that's going to make it easier for urbanization to continue. That really impacts urban sprawl because people can now move into the suburbs and commute to their jobs. It also requires a great demand for petroleum fuels, iron for steel production, and also that the land be set aside to develop roads and to develop urban areas. Once the car in particular became really common and we started doing more with fossil fuels, we now have to find a way to regulate the safety and the efficiency of these cars. And that is the job of the National Highway Traffic Safety Administration, NHTSA. They are responsible for two really common things that are tied into safety and energy efficiency. And both of these tend to go toward personal automobiles and light trucks, so things that are non-commercial. So an 18-wheeler really doesn't fall into this category. So the first thing they are responsible for is what is called a CAF standard. And CAF stands for Corporate Average Fuel Economy. And that sets guidelines for fuel efficiency for the majority of cars that a particular manufacturer releases. For a particular manufacturer, all cars and light trucks must get a minimum of 22.5 miles per gallon on average. If they do not, the company is fined $5.50 per every tenth of a mile per gallon that they are off that minimum. I mean, that's typically averaged over the total number of cars they sell in the United States. And these CAF standards are primarily focused toward cars that are produced in the United States. Foreign cars that are produced outside the United States have a couple different hurdles they have to go through in order to be sold in the U.S. The NHTSA is also responsible for what's called the Energy Policy and Conservation Act. And what that does is it seeks to encourage the use of domestic energy resources. At the time it was written, particularly domestic petroleum. This was written in the 1970s, right about the time of the Arab oil embargo. This is when we started really tapping our oil fields in Texas and Alaska. So the kinds of transportation that are available, we have personal private transportation and we have public or mass transportation. So personal transportation is going to be those things that you have, that you own, that you control. So your car, your motorcycle, and your bicycle. Those tend to be more convenient. They reduce your travel time, but they also contribute to pollution, congestion, and they have a lot of investment in upkeep. And you typically tend to lose a lot of your money in an automobile because they depreciate in value very quickly. The other side is public or mass transportation. And these are things that are available to the general public, typically for some kind of fee. And these are buses, trains, streetcars, taxis, and airplanes. So public transportation greatly reduces pollution and traffic congestion. It decreases the demand on particular resources, particularly petroleum, provides jobs and local revenue, and it's also cheaper in the long run than owning and maintaining a car. But unfortunately, public transportation is not always reliable, so sometimes it can be inconvenient, and the areas that it services may not be exactly where you want to go, so it might be a little bit of a hassle. Sometimes they are often underfunded, and sometimes there are some concerns about passenger safety. So how can we make transportation more sustainable? So there are three things that are going on right now, particularly in the auto industry, that are really focused on increasing the sustainability and the environmental friendliness of transportation modes. The very first one is the development of the electric car. When we talk about electric cars, we have to be very specific about which one we're talking about. There's something called a BEV, or a battery electric car, that runs solely on electricity. Or there are hybrid cars, which are cars that they run on electricity until the battery tends to run down, then they will start running on petroleum. The Toyota Prius is really the best example of a hybrid car. Then we have a new development which is called the hydrogen fuel cell car. And what that does is it takes hydrogen, puts it into a fuel cell that's under the car, and puts it through a reaction with oxygen. And what it does is it produces electricity and water as a byproduct. However, there are some issues with the efficiency of the fuel cell and the safety of the car, particularly with those hydrogen tanks in it. So it's not readily available on the market yet. The last thing is the development of biofuels. So particularly we're talking about ethanol and biodiesel. So these are oil products that are produced from plant material. And a lot of your biofuels are coming from soy and corn. They can greatly reduce the amount of toxic exhaust, but they're also removing a lot of materials from the feedstock of being able to feed humans. So the big debate there is whether or not we should be using this corn and this soy to produce more energy efficient biofuels, or if we should be using it to feed our growing population. And the last thing we're going to talk about with tropospheric ozone, with transportation, is tropospheric ozone. And this is one of the big problems that is associated with the large number of petroleum using automobiles, buses that we have on the streets. Before we start talking about this, I want you to make sure that you realize that tropospheric ozone is different than stratospheric ozone. Tropospheric ozone is a secondary air pollutant. Tropospheric ozone is bad. Stratospheric ozone is a necessary compound that is found in the atmosphere. Stratospheric ozone protects us from UV. Tropospheric ozone makes us sick. Tropospheric ozone occurs when you have nitrogen oxide compounds reacting with oxygen and sunlight in the atmosphere. So nitrogen-containing compounds are commonly produced from the exhaust of a car. So that compound reacts with oxygen, and that reaction is catalyzed by sunlight. And that forms an ozone molecule. That ozone gets trapped in the troposphere and combines with other compounds to form what is called photochemical smog. And these two substances are very common and very strong in areas with a lot of sunlight. So the cities of Los Angeles, Mexico City, they are highly susceptible to this photochemical smog. Again, please keep in mind, stratospheric ozone, good. Tropospheric ozone, bad. Right. Go back through your lecture if you have any questions. Make sure that you can meet all of these expectations.